So when we say rationalize the denominator of a fact, whenever you are given a sort to simplify, if that sort has a denominator, of course, that means it's a fraction, you have to rationalize the denominator. We don't leave our answer with sort at the denominator. That's why I say that I need to touch these two things before we continue with our simplification, because don't say that you are asked to simplify, you are not asked to rationalize, and you now solve a problem and leave sort at the denominator of your answer. That's not right at all. Okay, so whenever you are, unless you are asked to leave your answer in a particular form which comprises of sort at the denominator. So whenever you are asked to simplify a sort, and after simplification, you notice that there is a sort. There's any sort, whether it's 2 plus a number that is in sort form or what, as long as there is a sort at the denominator, you have to rationalize that denominator, because we don't leave our answer with a sort at the denominator. Now, let's take, for example, I have 1 over sort A, and I want to rationalize this. Okay, rationalize the denominator. All I need to do is change the denominator to a rational number. How will I do that? By multiplying sort A. But if you multiply only the denominator by sort A, it's not going to work. So what are you going to do? You multiply the numerator also by sort A. So when you multiply the numerator by sort A, multiply the denominator by sort A, you're going to have what? You're going to have sort A over A, making the denominator not to have any sort at all. Okay, so what we mean, that thing that you know that you will use to multiply the sort at the denominator to get a rational number, use it and multiply the numerator, use it and multiply the denominator. Okay, so that's for this. Now for this one, we do the same thing, but we don't just pick out sort A and use it and multiply the numerator and denominator. No, that's not how we do it. Okay, so you use the conjugate, because this is a compound sort. You use a conjugate of the denominator to multiply both the numerator and the denominator. When you do that, the sort at the denominator will disappear. Okay, so what I say, if you have a denominator of this nature, okay, so you just multiply the numerator and the denominator by the sort. Okay, so if you have a denominator of this nature, okay, that is of this nature, you make use of what? The conjugate, to multiply the numerator by the conjugate and also multiply the denominator by the what? Conjugate. Now, with all these that we have said now, we can now go ahead and do a lot of simplification, both the ones that have rationalization and others. Then we can now solve equations involving sort. So let us come back to simplification. Now that we have gained knowledge of conjugate of sort and rationalization of sort, of course, we can see that we are going to do something like that here. So what are we going to do? Now, is the choice is yours. You can first of all take care of your simplification, then find a way to get the sort at the denominator out. Okay, then you finish up your simplification. That's just it. So let us take care of our problem here. So this will give us 15 over sort 75, express it as a basic form. So that will give us sort 25 times 3 plus 108, express it in basic form. That will give you sort 36 times 3 plus 432 in basic form, 144 times 3. Okay, so this will give you 15 over 5 sort 3 plus 6 sort 3 plus this one will give you 12 sort 3. Okay, now this and this here will give us 3, so I'm going to have 3 sort 3 plus, take care of these two since they don't have any fraction in them, so that will give us 18 sort 3. Now we are not going to stop here. Like I said, you don't leave your answer with a sort at the denominator, so we need to get rid of this. But how can we get rid of that when this one don't also have that? So we first of all simplify this before we then rationalize, because this is a fraction. How do we solve a fraction? By taking LCM. So what's going to be our LCM here? That's going to be sort 3. So sort 3 divided by sort 3, that will give us 1. 1 times 3, that will give us 3. Plus, of course, we have over 1 here. So, 3 divided by 1, that will give us 3. 3 times this. Now, let us have that here. 18 3 times 3. That will give you 3 times 3. And 3 times 3 will give you what? 3. So, we have what? 18 times 3. Now, let us finish up that question here. So, that will give us 3 plus 18 times 3 will give us 54 all over 3, which will give us 57 over 3. But you can still see that we have our 3 here, so we need to rationalize now. So that will give us 57 over 3 times 3 over 3. So that will give us 57 3 over 3 will give us what? 3. Okay, so when you divide, 3 here will give us 1, 27. 3 here will give us 19, then 3. So this is our final answer. So you can see the way we solve. First thing we did is to put all these sorts in their basic form. Okay, we now simplify, take LCM. We now come here, after dealing with the LCM, we have this. Then from here, we rationalize. Now, this is a single sort, okay? This is a single sort, so it's alone. It's not a compound sort. So we just multiply the two, the numerator by this, the denominator by this to get this. Then we divide, you just divide and get your answer. So let us solve more problem of this nature. So here, more interesting question, because the previous question has just one sort at the denominator, but now we have two expressions with two sorts at the denominator. So 2 sort 7 minus 14 sort 7 plus 7 sort 21. What are we going to do? The same process. In this case, we can reduce this. We don't have factor that is a perfect square. There's a factor of 7. So for 21, we have 3 and 7. So none of them is a perfect square, so you cannot actually change. This is the lowest you can express this sort to. Now, what are we going to do here? You just take your LCM. So this over 1. So that will give you LCM. Yes, this is where we now need a little work, okay? LCM of 1 sort 7 sort 21. What is it going to give us? Okay. Now, if you check 1, of course, we know that that 1 is a factor of every number. Now, do we have a factor here? Yes. So 7, so 21. This will give you sort 7. This will give you sort 7 times sort 3. Okay. So this 21 here is the same thing with sort 7 times sort what? 3. Now, it makes 21 to be the LCM. So 21 divided by 1, that will give you sort 21. So 21 times this. So let us write it out. Sort 7 times sort 21, okay, minus sort 21 divided by sort 7, we're going to have what? Sort 3. So 3 times 14, that will give us 14 sort 3, plus sort 21 divided by sort 21, that will give us 1. 1 times 7, that will give us 7. Okay, now we have something here, which is sort 7 times what? Sort 21. Let us take care of that and see what we have. Sort 7 times sort 21 will give you sort 7 times 21. That will give you 7 times this is 7. 7 times this is 1, 4. Okay. So we have 1, 4, 7. So that will give us 2, 1, 4, 7 minus 14 sort 3 plus 7 all over sort 21. Okay. Now we need to check that 147 if there is anything there that we can actually bring out. What I mean by bringing out, is there a perfect square in 147? Yes, there's a perfect square in 147. That will give us sort 49 times 3. Okay, sort 49 times 3, which will give you 7 sort 3. So we can bring it out. So let's bring it out there. That will give us 2 times 9 sort. Okay, sorry. 2 times 7 sort 3 minus 14 sort 3 plus 7 all over sort 21. So let us finish it up here. So that will give you 14 sort 3 minus 14 sort 3 plus 7 over sort 21. That is interesting. So you can see that 14 will go. So that will give us 7 over sod 21. Now you can't leave your answer this way, okay? Because there's a sod at the denominator. So you need to rationalize. So that will give us 7 over sod 21 times sod 21 over sod 21. So that will give us 7 sod 21 over 21. Now, this one here, 7 here will give us 3, 7 here will give us 1. So that will give us 7, that will give us sod 21 over 3. Okay, so that's how to solve that particular problem. Okay, so let's look at another question. So let's take care of this. Now you have a bracket, you have a number outside. So the same way you open your bracket, that's the same way you're going to do this, but you are going to put the sod in consideration. So when you multiply this and this, you are going to have 36 over, so 3 times so 3 will give you 3. Then you multiply this and this, 3 times this will give you minus 3 sod 12 over, this and this will give you 6 sod 3. Okay, so this will give you here, we have 12 minus, so 3 here will give us 2, 3 here will give us 1. So we have sod 12 over 2 sod 3. Now, we are not going to be quick to rationalize or even simplify because 12 can still be put in basic form. So that will give us 12 minus. Now, in basic form of sod 12, sod 12 will give us sod 4 times 3, which is equals to 2 sod 3. So that will give us 2 sod 3 over 2 sod 3. So you can see that these two here will cancel out. Our answer be what? 12. All right. So you can see that, or you will notice that most of the problems that we have been solving on so far, most of the problems we have been solving so far, they just have a single sod in them, okay? Just a sod that is alone. Now we are going to look at when we have compound sod, okay, so that we can be able to make use of conjugate of a sod to simplify. So a problem like this can be, how would they ask this question? They can ask you to simplify, or they can ask you to rationalize the denominator. Okay, they can even ask you to express this in another form. Okay, I'm not going to go that now because our next question will take care of that. So when you're asked to simplify this or when you're asked to rationalize this, what are you going to do this time around? What we have at the denominator is not just one sod. Okay, it's now two numbers together, which we are going to make use of the conjugate. Okay, so here we are going to have 3 over 3 minus sod 6. So we multiply the numerator and the denominator by the conjugate of the denominator. So that will give us 3 plus sod 6 over 3 plus sod 6. So that will give us 3 into 3 plus sod 6 all over 3 minus sod 6 into 3 plus sod 6. Okay, so this is what we have now. Now, we need to open this bracket. Now, let us talk about whenever a sod multiplied by its conjugate, so that each time we encounter it, we'll know what to do. Okay, if you have sod A minus sod B times sod A plus sod B. Now, if you have done your algebra very well, you will notice that this, what you have here, is difference of two squares. And what is difference of two squares? That will give you that if a square minus b square will give you a plus b or minus b, whichever one you decide to come first. So this is a difference of two squares, and that's what you have here. So what you have here is the same thing with sod a all square minus sod b all square. And we know that sod a all square will give you a, and sod b all square will give you what? B. So what does that mean? Anytime I have two sods that are conjugate to each other multiplying, is going to give me the first term square minus the second term square. So let us leave this one from it, because sometimes you might have a number, not a sod. Okay, so first term square minus second term square. So we are going to apply it here. Now let's open this bracket here. 3 times this will give us 9 plus 3 times sod 6 will give us 3 sod 6 all over 3 square minus sod 6 square. Okay, remember that's what we have here. So that will give us 9 plus 3 sod 6 all over this will give us 9 minus 6, which will give us 9 plus 3 sod 6 over 3. Now, if you watch here, yes, I know that we have opened this bracket already, okay, but 3 can actually divide by this 3. So let us put this bracket back. So that will give us, let's finish it up here. Factorizing this back, we have 3 into 3 plus sod 6, okay, all over 3. So this 3 now will cancel out this. So that will give us 3 plus sod 6. So that's what we have. So now let us solve a problem which you'll be asked to rationalize, and they will not tell you in a particular form to leave your answer. So in this question, they are actually asking you to rationalize without saying it. Okay. So you are asked to, this is equals to this. So what they are saying, telling you is that express this in this form, then find the value of a, b. Okay. So let us solve that particular problem there. You can see the kind of denominator we have to multiply by the conjugate. So that will give us 2 sod 5 plus 4 sod 2 all over sod 5 minus sod 2 times the conjugate of sod 5 minus sod 2. That will give us sod 5 minus sod 2 all over plus all over sod 5 plus sod 2. Okay, so that will give us 2 sod 5 plus 4 sod 2 into sod 5 plus sod 2 all over sod 5 minus sod 2 into sod 5 plus sod 2. Okay, so you can see that we have a bracket to open there. Now let us gradually open that bracket here. Now 2 sod 5 times sod 5, that's just like saying 2 sod 5 times sod 5. These two will multiply, so you have 2 times 5, which will give you 10. So 2 sod 5 times sod 5 will give us 10. Okay, 2 sod 5 times sod 2 will give us plus 2 sod 10. Why? 2 is there, so there is no number that can multiply by 2. Then sod 5 times sod 2 will give you sod 10. Then you now come to the second one, 4 sod 2 times sod 5, that will give us 4 sod 10. Okay, that's the same way. Sod 2 times sod 5 will give us sod 10. Then you now have your 4. Then 4 sod 2 times sod 2, that will give us 4. That will give us 4 times 2, which is of course 8. Okay, but let's leave it that way first. Or this one also, let's write it as 2 times 5, because sod 5 will give us 5, so that uh, we can actually follow the steps. Then for the denominator, okay, remember this is the difference of 2 square, so that will give us sod 5 all square minus sod 2 all square. So that will give us, here we have 10 plus these 2, they are like terms, so that will give us 6 sod 10. Then here we have 8 all over, this one will give us 5, because square root of 5 times 2 raised to power 2 will give us 5. Then this one will also give us 2. So this and this will give us 18 plus 6 sod 10 all over 3. So you can see that in that 18 plus 6 sod 3, we can actually factor 3 out. So when you do that, you have 3 into 6 plus 2 sod 10 all over 3. So this and this will go, we have 6 plus 2 sod 10. Okay, so remember, you are not asked to simplify, rather you are asked to find a and b. we just need to simplify to be able to find our A and B. So from what we have, we can now say therefore A is equals to 6 and B equals to 2. So that's our answer. So let us solve more problems of sort like that. So our next question, we are asked to express 2 over 1 minus or 2 minus 2 over 2 plus so 2. We should express it in this form. So they want the whole of this to look like this. Okay, so let's start. Now, this is a fraction in as much as it's a solid. So we take LCM. LCM will give us 1 minus or 2 into 2 plus or 2. So this divided by this will give us this times this will give us 2 into 2 plus or 2 minus this divided by this will give us this times this will give us 2 into 1 minus or 2. Okay, so opening your bracket, you are going to have 4 plus 2 sod 2 minus 2 plus 2 sod 2 all over this, and this will give us 2, this and this will give us plus sod 2, this and this will give us minus 2 sod 2, this and this will give us minus 2. That's because sod 2 sod 2 will give us what? 2. So that will give us 4 minus 2. That will give you 2. So 2 sod 2 plus 2 sod 2 will give you plus 4 sod 2 all over this, and this will go, okay, and this will give us minus sod 2. All right, let's finish it up here. So that will give us we can see our minus here, so we need to remove this. So that will give us 2 plus 4 sod 2 over minus sod 2 times sod 2 over sod 2. It will give you the same thing. So this and this will give us um 2 sod 2. This and this will give us plus 4 times 2 all over this, and this will give us minus 2. So factor 2 out here, you have 2 into sod 2 plus 4 over minus 2. So this and this will go. So you have minus in brackets sod 2 plus 4, which will give you minus 4 minus sod 2. Okay, now our P is minus 4, our Q is minus 1. That's why we don't normally write it. Then our M is the what? Is 2. So we have expressed this sod in this form. Okay, so let us look at another type of question. So we are asked to simplify this. Okay, now before we continue simplifying, notice in this part there's an inverse. Okay, so what happens whenever you have an inverse? If you have A over B raised to power minus 1, that thing simply means 1 over A over B. And when you have 1 over A over B, it will give you B over A. So the only thing that happens whenever you have inverse is for the denominator to come up as the numerator, and numerator will go down as the what? Denominator. Let's apply that in this question. So this will give us 1 over 2 minus 3 plus, this one will now give us 2 plus 3 over 2. So you take LCM between this and this, that will give us 2 into 2 minus 3. So that's our LCM. So this divided by this, we have 2. 2 times 1 will give us 2 plus this divided by this, that will give us 2 minus 3. 2 minus 3 times this will give us 2 plus 3 into 2 minus 3. Okay. So if you look at these two here, you can see your difference of 2 squared there. So we are going to take care of that. So we have 2 plus into 2 square minus 3 all square. Okay, so that's what we have here. Is difference of 2 square. So 2 square and 3 square all over. This one will give you 2 into 2 minus 3. So we still leave it like that because I can see that we might still have something that we can subtract here. We are going to have 2 plus 4 minus 3 all over 2 into 2 minus sod 3. Okay, so that will give us this, everything here, or this one here will give us 1 plus this will give us 3 over 2 into 2 minus 3. Now, we can now rationalize, okay, or we open the bracket and rationalize, because you cannot leave your answer in this form unless you are asked to do so. So that will give us 3 over 4 minus 2 sub 3. So rationalizing, we have 4 plus 2 sub 3 over 4 plus 2 sub 3. So you can see the middle sign have actually changed. So that will give us 3 into 4 plus 2 sub 3 all over, do the same thing, this square minus this square. So that will give us 4 square minus 2 sub 3 square. So that will give us, if you open that, okay, let's still leave it, 3 into 4 plus 2 sub 3 all over, this one here will give us 16 minus 4 square, 2 square will give us 4 times 3 square will give us 3 square will give us okay, so 3 square will give us 3. So that will give us, here something is still common here, which is 2. So bring it out. So that 2 coming outside will multiply by this 3. So that will give us 6 into 2 plus 3 all over. Here is 16, here is 12. So 16 minus 12, that will give us 4. Okay, so 2 here will give us 2. 2 here will give us 3. So our final answer is going to be 3 into 2 plus 3 over 2, which can be expressed in different form. You can write it as 3 over 2 into 2 plus 3. You can express it in different form, but the most important thing is that we no longer have sod at the denominator. Okay, so that's how to solve that particular problem.